Okay, so here by the end of class, you're going to have your quiz number 8 that you were supposed to have before break when we had that little issue on that Tuesday. But this one will cover, counting protons, neutrons, and electrons, average atomic mass, and everything that I'll show you here in this little review. Remember, we have something called nuclear notation, and here down in the lower left-hand corner, we have the atomic number, which is the number of protons. The atomic number and the number of protons are the same thing. So this here, the symbol is aluminum, 13 positive protons. In the upper left-hand corner is the mass number, which is the total number of protons and neutrons in this atom, and it's a way for you to figure out the number of neutrons. So if you have 26 protons and neutrons, you know 13 of them are protons. So the difference is there are 13 neutrons. The number of protons plus neutrons will equal the mass number. The upper right-hand corner is a way for you to figure out the number of electrons. So this says it has a plus 13. So that means since you have, and that's the charge, so since you have 13 positive protons and an overall charge of plus 3, you must have 10 electrons. So 13 positive protons and 10 negative electrons gives you an overall charge of plus 3. And remember, we also have something called hyphen notation. In this case, for this one, it would be called aluminum 26 plus 3. So it's got the name, the mass number, and the charge. And it's the same way. You know aluminum is 13. You can figure out the number of electrons because it's 13 positive protons. It would be 10 negative electrons to balance out to a plus 3. You can figure out the number of neutrons. It'd be 26 minus the proton count of 13 to give you 13 neutrons. So hopefully you remember how to do that. This will certainly be something that's on your quiz here. So if you'll remember, we did a couple of things like this before break, but part of your quiz will look like this. You're going to have some bit of information about different elements, like here in the first one you're given the nuclear notation. That's indium 11549 plus 3. So the atomic number is 49, which means the number of protons are 49. Those are always going to be the same. You can figure out the number of neutrons because the total 115 protons and neutrons, you subtract out 49 of them that are protons, and you're left with 66 neutrons. So the number of protons and neutrons will add up to the mass number. The number of electrons is figured out because there's a plus 3 charge. You have 49 positive protons. You must have 3 more protons than electrons, so 46 negative electrons. The mass number, it's given to you in this case, it's 115. Second one, you're given just the atomic number of 93. All right, so you have your periodic table. You go look at number 93. It's neptunium. You don't know there's a charge or anything, so it's just neptunium. Number of protons in the lower left, mass number in the upper right. 93 protons means the atomic number of 93. They're always the same. Number of neutrons would be 237 minus 93, 144. The number of electrons, since you don't know that there's no charge written and you don't know there's a charge, if you have 93 positive protons, you would have 93 negative electrons to balance it out. The mass number you're given is 237. Okay, the third one is you have a mass number of 257. Okay, you look on the periodic table for the one that has a mass of 257, and that's the one with an atomic number of 100. That's fermium. So fermium 257, with the 100 down here, the number of protons. So the atomic number and the number of protons is 100. The way you figure out the number of neutrons is, well, it's the difference between the mass and the proton count. So it's 157 neutrons to go with the 100 protons makes a mass of 257. The number of electrons, there's no charge given, so it must be balanced out. 100 positive protons means 100 negative electrons, so that there is no overall charge. If you go to the last one down here, 88 protons. All right, so the atomic number is the same, and that means it is radium. 88 is the number of protons. The upper left-hand corner is the mass number. Right off the periodic table, it's 226. And to find out the number of neutrons, well, it's 226 minus 88, and you get 138 neutrons, 88 protons, a mass number of 226. And it says you had 88 positive protons and 91 negative electrons. That means an overall charge of -3. You have 3 more negatives than you do positives. So hopefully you remember these kind of things. You'll see that again on the quiz here in a little bit. You'll also see empirical and molecular formulas. And remember, we're looking to change either percent or grams data into a count of how many nitrogen, how many hydrogen, how many sulfur, and how many oxygen in this example. All you have to do is, whether you're given grams or percent, it doesn't matter. Just go ahead and put those numbers down. 21.2% nitrogen, 6% hydrogen, 24.3 sulfur, and 48.45% of it is oxygen. And we're going to convert those masses, those numbers, into moles, into a count, by dividing every one of those numbers by the molar mass of those elements. Go ahead and do that math, and it's going to give you some numbers. If they're all whole numbers, then you're done. But almost always it's not going to be a whole number. And what you're going to do is you're going to divide every single one of them by the smallest one of them. And it'll always work out. It'll change them to whole numbers. So 1.5 divided by 0.75, 6 divided by 0.75, this 0.75 divided by itself, and 3 divided by 0.75 gives you a ratio, an empirical formula of 2 nitrogens for every 8 hydrogen, for every 1 sulfur, for every 4 oxygens. Doesn't mean that's necessarily the real formula, the molecular formula, but that is the ratio of those atoms. Okay, so that is the empirical formula. Now, to find the actual molecular formula, you're going to compare the molar mass of this thing with the actual molar mass, and in this case you're given the actual molecular molar mass of 396. You find that your empirical formula is mass by adding up 2 nitrogen, 8 hydrogen, 1 sulfur, and 4 oxygens is 132. Okay, well, the real thing is 396 grams per mole. Your empirical formula is 132, so, and this is always also going to work out to a whole number. So you end up that the real thing is 3 times bigger than the empirical formula. Okay? So you're going to take that empirical formula, you're going to multiply everything by 3, by the fact that the molecular formula is 3 times bigger. So you end up with N6H24S3O12, the molecular formula. So you take those percentages or mass data, you make them the subscripts, you convert them to moles by dividing by the molar mass. If they're not all whole numbers, you divide by the smallest one to get the empirical formula. You find its molar mass, you compare it to the real molar mass, and it's always going to be a whole number multiplier, 1 or 2 or 3 or whatever, and to get the actual molecular mass. Right? You will also see average atomic mass on the quiz here coming up in a little bit for you. But no matter how many isotopes there are, you're going to be given an abundance, a percentage. So for whatever this element is, I know that 90.92% of it weighs 20, so it has 20 protons and neutrons. 0.257% has 21 protons and neutrons, and 8.82% has 22 protons and neutrons. So you're just going to find the average. So you're going to take the abundance times its mass. So 90.92 times 20, 0.257 times 21, 0.882 times 22. Okay, and then so the abundance adds up to 100. So to find the average, you're going to take the percentages times its mass plus the percentage times mass for however many isotopes you have, and divide by the total you have, and their percentages, so the total is 100. And you're going to get, in this case, 20.18 atomic mass units. So the almost 91% of them weigh 20, a fraction of a percent of them weigh 21, and almost 9% of them weigh 22. But on average, they weigh 20.18, and this number should be somewhere in between the heaviest and the lightest. All right, so these are the kind of things that are going to be on your quiz in a little bit. Um, Take a little bit of time. I think your sub is going to give you the last 45 minutes of class to take the quiz. And when you come back, when I come back and you're back in here on Thursday, we will start talking about nuclear stuff. And on Monday, you will have quiz 9. And on Friday of that week, you will have quiz 10. So next week, you will have the last 2 quizzes. And again, quiz 8